Hey there, statisticians. So what we're going to talk about in this video is I'm going to talk to you about what standard deviation is and how we are going to calculate it. So I'm going to define for you sample standard deviation and population standard deviation of a data set. So what is a standard deviation? Simply put, a standard deviation, oh, by the way, you should have this out and you should be taking your notes right here when you understand what you want to put down. Write it here, and this is kind of a picture that I'm going to show you. So what is a standard deviation? What a standard deviation is it tells us how far our data is from an expected value. And that expected value is going to be the mean of my data set. So picture-wise, what this is, if I give you a nice normal distribution like this, here is my expected value, my mean. We traditionally have 3 standard deviations up and 3 standard deviations down. A standard deviation measures how far from the mean to each standard deviation we go. So from here to here is the same distance as 1 to 2. Mean to 1 is the same distance as 1 to 2, and that's the same distance as 2 to 3, going up or down. So that is what a standard deviation tells us. It tells us how far our expected value is from my expected value, which is my mean. So, oops, I backed up instead of going forward, my bad. So here's some of the ways that we're going to compute this. Do not write this down because this is not how we're going to do it. I just wanted to show you how this is found out. So of course, x is going to be any data value. X bar or bar x is the average or the mean of my data set. It's what we expect to get. When I ask you what is an expected value of a data set, that is always the mean. Then we're going to find the difference between each data value and that mean. We will square that difference and add it up. And then we can find the sum of the squares. We can either do this or this one. This is the computation formula. Computation formulas are just a little easier to work out. Like I said, don't write it down because we're just going to use our calculator to find standard deviation. But you need to know all of this because we're going to have what's called a sample variance, which is this formula right here. And then we've got our standard deviation formula right here. Well, do you want to do this every time that we're doing standard deviation, or do you just want to plug it into your calculator? And that answer is, we just want to plug it into our calculator, which I'm going to show you how to do in class. Okay, but I just want to talk about what it is. So why do we have sample standard deviation? Why is it called a sample standard deviation? Well, if we have a data set and we're taking a sample of that standard deviation, we're going to find S. S stands for sample deviation. Why it's important to differentiate is a sample standard deviation can change depending on the sample that I choose. If I've got 100 people in a group and I get a sample of 20 and then I get a different sample of 20, the standard deviation can change from each sample. Okay, so that's what's important to know. So we have our defining formulas again. So please write in this formula, though. I would like you to write in the computation formula for standard deviation and variance. So if you need to pause the video, please do so, because we're probably going to talk about our sample variance and sample standard deviation. This one we're going to need to figure out, but this one our calculator will tell us. And then we have a population standard deviation. Those 100 people, we can take all 100 people. There's no need to break it down into smaller groups, except now instead of saying S, for my standard deviation, we're going to say sigma, little sigma right here. This, not the big E looking sigma, the little sigma. Population standard deviation cannot change because if I do all the people of a group, it's always that standard deviation. That's why it's important to note the change. S can change, sigma does not. So to find the formulas for our group, here's our population mean. Notice it's big N instead of little n, denoting it's a population, not a sample. And then we can have our sigma squared and our sigma. Okay? So here you can pause this and take a look at it. It's why are the formulas different? Okay? We don't need to know necessarily why the formulas are different. Just understand that they are. So if you'd like to pause the video, and I'm going to move my picture around so you can read it at any point, go ahead and do so. And as always, Patriots and statisticians, if you got any questions, please let me know. I'd love to help.